here I'm trying to draw a donut where this is supposed to be like the body of the donut, and then I want to have a white disc corresponding to the hole in the donut right in the middle. And so I've named some parameters, 50 in for the inner radius and 150 out for the outer radius. And so this inner radius, that corresponds to a smaller disc here. And I kind of want to remove that from this donut. So why didn't it happen here? Okay, well, where's this white disc? Well, when Mathematica draws graphics objects, okay, you give it the graphics objects in a list. Okay, here's the first element in the list. Here's the second element in the list. And the way Mathematica chooses to draw those is it draws the first one, and then it draws the next one on top of the first one. So because the first one was smaller, when it drew the bigger one, it was on top of it, and so the first one just got completely subsumed by the bigger one. So let's switch the order of these. Okay, so I cut that, and I'm pasting it here at the front. Okay, now that looks more like a donut. But I want to add some extra to the donut, and what I want to add is some sprinkles. So let's add, say, 50 sprinkles. And how am I going to represent those sprinkles? Well, I'm going to use discs, but much smaller than the two discs I've drawn here. I'm going to use discs of radius 1. Okay, so here was the radius of this. It was radius 150. So I'm going to use much smaller discs here. And where do I want the centers to be? Well, I want the x of the center to be between negative 150 and 150. And I want the y of the center to be between negative 150 and 150. So let's first just get the possible coordinates for either x or y. So let's do table I for I from negative 150 to 150. And that's okay, but it would really be more robust to, instead of typing this 150, to type out, so that if I later want to change the radius, I can just change it up here, and it will automatically change for the coordinates down here. So those are single numbers. Okay, there's going to be a list of, I guess, 301 single numbers. And how can I get pairs of numbers corresponding to the center of the discs? So here's one way. I can call this, how about centers? And let's use the tuples command. So we want to take all pairs from the coordinates list. Okay, and those will be the centers of the sprinkle discs. And now let's make the discs corresponding to the sprinkles, and I only want to have 50 of them. So let's start by choosing 50 randomly from these centers. So let's call it, how about, limit for limited centers. And we're going to use random choice to just choose 50 of these possible centers. So from the list centers, I want to choose 50, okay, which I'll call sprinkles here. So let me just evaluate this and see if I've made any mistakes. And let me try to show you what some of these things look like. So let's look at coords. Okay, there's this list from negative 150 to 150. Then centers. Okay, here's the list of possible centers of our sprinkles. And then here, rather than this huge list that I can't compute how big it would have been, here I just have a length 50 list. Okay, 50 because that's how long I told it, or how big of a collection to choose from the centers list. Okay, and let's see, let's just call it SP for like sprinkle list, or how about SP list? And then let's have table, and we're going to make this using the second type of iterator. So let me leave the first part of the table command blank for now, And let's choose C for center out of the limited list. And then for each of those, I want to make a disk with that center and of radius 1. And I also would like to add a color to this disk. So let me just choose a random color. I'm going to use this function random color here. And let's evaluate. So this showed up because I didn't have a semicolon. Let me evaluate it again. And so let's look at this sprinkle list, this SP list. And so that doesn't look great, but what if I put it in graphics? Okay, there are some sprinkles. So let's try to combine that with this list here. So let's call this total list. And let's join these two lists together. So I have SP list, and I want the sprinkles to go on top. So that should come second. And then first we can put in this list. Okay, so I'm joining those two lists together. Okay, and then let's make this total list for the graphics. So that's pretty good. One problem is that notice how some of these sprinkles did not land on the donut. So how can I get rid of that? Well, here's one way. I have these tuples corresponding to where the sprinkles can go, and let's remove all of the sprinkles that would be in this inside hole or that would be outside the outer boundary of the donut. And let's do that using cases. So let me do res for restricted list. And let's do cases of my centers list. And remember, these are going to be pairs of numbers, like maybe 40, comma, negative 130. And so I only want those points, those x, such that, well, I want them to be between this inner radius of 50 and the outer radius of 150. So I want the distance from the origin to be between this in and this out. So remember, x, it's chosen from centers, so it's a pair of numbers. Here's the first element in the pair, x double bracket 1. And here's the second number in the pair, x double bracket 2. Okay, and here's the radius, and I want that to be between the inner radius and the outer radius. Okay, and then rather than choosing from the whole centers list, I want to choose it from this restricted list. Okay, so let's try again. Okay, now you can see that all the sprinkles are inside the donut. And what if I want to use more sprinkles than this? Okay, well, I can do that very easily. Okay, instead of using 50 sprinkles, let's use 20,000 sprinkles. And right now it's thinking as it tries to choose those. And so here the donut is covered with these 20,000 different sprinkles.